Today we'll see relationship between zeros and coefficients of a polynomial. In general, if alpha and beta are zeros of a quadratic polynomial, p of x which is equal to ax square plus bx plus c, where a should not be equal to 0, right? If a becomes 0, it will no more a quadratic equation. That's the reason this is the condition given. Then x minus alpha and x minus beta are the factors of p of x. See here, already they are saying alpha and beta are the zeros. It means that x is equal to alpha and x which is equal to beta. These are the zeros. It means x minus alpha is one factor and x minus beta is the another factor. Correct? Now, here you see our polynomial I will write down in the factor form. So this is our polynomial which is equal to k in the bracket x minus alpha and in another bracket x minus beta, where k is constant. Why we have written k here? Just imagine our polynomial is like this way: 2x square plus 4x plus 6. So from all these terms we can take 2 common. So our polynomial will become x square here plus 2x plus 3. Correct? So this is the constant number. Right? So if I will find out the zeros, this one 0 for this polynomial and zeros for this polynomial will be same. Only what? This common factor is there. So that's the reason we have written here k. Okay. Now here k as it is, we multiplied both the brackets. As we multiplied both the brackets, we are getting this format. Now with k we are multiplying each and every term. This format we got. Now what we'll do, we'll compare the coefficients of this polynomial and here coefficients of this polynomial. Okay, now just see here properly. Here value of a which comes as k. Look, coefficient of x square here at this place a and coefficient of x square at this place k. So that's the reason I have written a which is equal to k and I have named it as 1. Now here coefficient of x is b and coefficient of x is minus k in the bracket alpha plus beta. Don't forget the sign. Along with the sign we are going to write down. So b which is equal to minus k in the bracket alpha plus beta. And here c means constant. So this one is a constant. No variable is there. So c which is equal to k alpha beta. Correct? So here I have written this one. Second equation, b which is equal to minus k in the bracket alpha plus beta. But value of k is what? A. So it at place of k I substituted a. Therefore it is written from 1. So here alpha plus beta, this minus a we have sent to the left hand side to divide. So we got this format, alpha plus beta which is equal to minus b by a. Remember this format is very very important. Okay, so alpha plus beta are the zeros and this minus b and a are the coefficients. So at one side zeros are there, on the another side coefficients are there. So this is the relationship between zeros and the coefficients. Look at the another relationship here. C which is equal to k alpha beta. From 3 we have written this one. But value of k is what? A. Now this a will send to the left hand side, which is multiplying here, it will divide that side. So we got alpha beta which is equal to c by a. This is the another relationship. This side these are the zeros and these are the coefficients, right? So these two things are the relationship between the zeros and the coefficients about the quadratic polynomial. Look at this here once again. We'll repeat. Alpha plus beta which is equal to minus b by a and alpha beta which is equal to c by a. Correct? In short, what? If alpha and beta are the zeros or you can say roots of a quadratic polynomial p of x, ax square plus bx plus c, then sum of the roots which is equal to alpha plus beta which is equal to minus b by a. The meaning is what? Minus b means what? Coefficient of x divided by a means coefficient of x square. So this is the relationship between zeros and the coefficients. And if we want to write down the products, The product of zeros equal to alpha beta, which is equal to c by a, which is nothing but constant term divided by coefficient of x square. Let us take one example so it will be more clear for you. Okay, now here we are having the polynomial. I will just equate this polynomial with 0 now. Why? Because we want to get the zeros of this polynomial. Now, as it is a quadratic polynomial, I want the product as 10. See here, product as 10 and sum as 7. Two numbers. So, 5 and 2. So, looking at these two numbers, directly I can write down the factors. So, x plus 5 here and here x plus 2. These are the two factors of the given polynomial. Now, I will equate each factor with 0. So x plus 2, which is equal to 0 here, I can say or. So x which is equal to minus 5 or x which is equal to minus 2. So this first factor I will name it as alpha, which is equal to minus 5, and second factor beta, which is equal to minus 5. You can say this one as beta and this one as alpha, no problem. Okay. Now I got two zeros of the given polynomial. Now I want to show the relationship between the zeros and the coefficients. So first I will write down sum of zeros. Here I can say now sum of zeros means what? Alpha plus beta. So minus 5 minus 2, which comes as minus 7. Right? See, let me write down properly here, which is equal to minus 7. And minus b by a. Now look at our polynomial. Here, minus sign already. Value of b is what? 7. Right? And value of a is what? 1. B means coefficient of x and a means coefficient of x square. So here we can write down minus 7 by 1. So this value and this value is same. Right? Therefore you can say alpha plus beta, which is equal to minus b by a, which is equal to minus 7. So these values are coming same. Now we'll go towards the product of the zeros. So product of the zeros means what? Alpha into beta. Minus 5 into minus 2, which comes as 10. And c by a. C means constant term. So constant term in the polynomial is what? 10. A means 1. So it will become 10 by 1. Here 10 by 1. See once again, this value and this value is same. So directly we can write down here alpha into beta, which is equal to c by a, which is equal to 10. This is the another relationship. Correct? So this way we can show the relationship between the zeros and the coefficients of the given polynomial. Right? Let us see the second point. If alpha and beta are roots of a quadratic polynomial p of x, then p of x is equal to x square minus alpha plus beta x plus alpha beta. This is the format to write down the quadratic equation if the roots are given. Let us see one example here. Find a quadratic polynomial whose zeros are 2 and 3. Right? That means we have alpha, which is equal to 2, and beta, which is equal to 3. We know the format to write down the polynomial. So here I write down p of x, which is equal to x square minus 2 plus 3, because alpha plus beta, x, and plus alpha into beta, this one, which is equal to x square minus 5x plus 6. This is the quadratic polynomial, right? Let us see the another point. Similarly, if alpha, beta and gamma are the three zeros of a polynomial p of x, a x cube plus b x square plus c x plus d. This is the format of the cubic polynomial. Then sum of the roots alpha plus beta plus gamma, the formula is minus b by a. Sum of product of roots, so alpha beta plus beta gamma plus alpha gamma, which is equal to c by a, and product of roots alpha beta gamma, which is equal to minus d by a. Right? They have given us the cubic polynomial. From here, first we'll write down the coefficients. So coefficients are here. I will write a, which is equal to 1, b, which is equal to minus 3, c, which is equal to minus 1, and d, which is equal to 3. Correct? I have written the coefficients first. If I write down the sum of roots, that means alpha plus beta plus gamma, which is equal to what? Minus b by a. So minus b means what? Minus, and value of b is minus 3 by a. A means 1. So our answer comes as 3. So this is the sum of the roots. Now sum of product of roots. That means alpha beta plus beta gamma plus gamma alpha, you can write down, or alpha gamma, one and the same, which is equal to alpha into beta. Okay, fine. So here, what is the format they have given? C by a. C is what here? C is minus 1. And a is what? A is 1. So our answer comes as minus 1. Now finally, the product of the roots. So product of the roots means what? Alpha, beta, gamma, which is equal to minus d by a. Minus, value of d is what? 3. And a is what? 1. Right? So our answer comes as minus 3. Correct? It means that when you will find out really the roots of this one cubic polynomial, and then when you will add those roots, you will get this 3. When you will do the sum of the product of the roots, you will get the answer minus 1. And here only the product of roots, answer will become minus 3. Right? Now let us see the fourth point. If alpha, beta, gamma are the roots of a cubic polynomial p of x, then the format of writing the cubic polynomial is this one. See here. In this case, you are supposed to be careful about the negative signs. For the first term, positive sign, then for the second term, negative, then positive, and then negative. Clear? So you have to remember this format to write down the cubic polynomial. Now for example, find a cubic polynomial whose zeros are 1, 2, and 3. So they have given us the zeros. It means that they said alpha, which is equal to 1, beta, which is equal to 2, and gamma, which is equal to 3. And now we need to write down the polynomial. So p of x, which is equal to x cube as it is, minus alpha plus beta plus gamma. Look at this one, 1 plus 2 plus 3. If you'll do, our answer comes as 6. So here I'll write down 6x square plus, now alpha beta. So alpha beta means what? 1 into 2. So it comes as 2. Beta gamma. So 2 into 3. It is 6. And gamma alpha 1 into 3. This is 3. X minus product of the roots. So alpha into beta into gamma. So 1 into 2 is 2. 2 into 3 is 6. So here 6. So finally our polynomial is x cube minus 6x square plus 8 and 3 11. 11x here minus 6. This is the required cubic polynomial when they give us the zeros. Correct? I hope all of you understood this one. Relationship between the zeros and the coefficients, and how to write down the polynomial when they will give us the zeros. Correct?